We are moving into section 3 where we're going to be multiplying fractions. Our directions say to multiply and then simplify each expression. So first we're going to carry out the multiplication, and then we are going to finish off by simplifying what we're doing. We go to our handy dandy flowchart here. What we will find is that we are going to start where we start every time, at the start. And we are going to move our way from here all the way through, and we're going to multiply. So we're going to head in here and do these steps, and then since we are multiplying, we will always end by simplifying down here. So we will do these steps one more time, and what you'll find is that compared to section 2, it is almost identical, because the multiplying step really is only adding one thing from what we were doing before, and it's multiply straight across to create a single fraction. Otherwise, we are just simplifying that single fraction. So let's see what that one step looks like in practice. I'll go through once and then we'll go through with the flowchart. So first problem here, we have 8m over 7 times 6m over 9. We have two fractions. They are being multiplied times each other. So we're going to zoom into this. And what we're going to do is we're going to start the way we always start, which is by wrapping these in parentheses. And since there are two fractions, we have two sets of things to wrap in parentheses. So if we go back to our flowchart, that was our first step. Parentheses are on the entire numerator and entire denominator, and that's of each fraction if there's multiple fractions. Second step is to decide which operation. That's multiplication, so we're going to follow it down here. And it says multiply straight across then to make a single fraction. So multiply straight across means take this times this and multiply this times this. If you've heard the term cross multiply, remove it from your brain right now, because it is only going to cause you problems for the rest of this unit. So just forget that evil word phrase. Pretend you never heard it. This is what we now get. We now have one fraction. We multiplied the two tops, two numerators, into a single numerator. And we multiplied the two denominators into a single denominator. And when we multiply, remember that writing two things with parentheses around them with a little dot between them, or even just writing two things with parentheses without the dot, means that we are multiplying those two things. So the way we wrote it here is a multiplication problem already. We are done with that step, and we are heading on to our final step of simplifying, which means we're going to now continue to factor everything fully, look for excluded values, and then eliminate things from top to bottom. So let's go ahead and do that. So when we break down these factors here, 6 is really going to be 3 times 2 times m, and 8m, we could do 2 times 2 times 2 times m, and on the bottom, 9 is 3 times 3. And now I'm going to look for things from top to bottom that are going to reduce. And so I see that I have a pair of 3's here, and that's literally it on this particular problem. There's actually almost nothing that simplifies, which is sometimes the case. So on top I have 2 times 2 times 2 times 2 is going to be 16. M times m is going to be m squared. In the denominator I have a 7 times a 3, so that's 21. So our final answer here would be 16m squared over 21. Now if I go to my flowchart, it'll say before eliminating, check the denominator for excluded values. So going back, let's just look real quick at what I had. I had a 7 and a 3 and a 3 when I factored it out. And you'll notice I have no variables, no m's in this case, in the denominator. So there's nothing I could plug in for m to make the denominator 0, because the denominator is actually a real number. Whatever 7 times 9 is was the original denominator, and there's nothing I can do to change that into 0, short of scribbling out what was written there and putting a big 0 there. You can't plug anything for m if there is no m there. So in this problem there are no excluded values. And then finally it says eliminate factors top to bottom. We skipped ahead and did that, giving us our final answer, 16m squared over 21. Let's look at something that's a little bit more complicated now. We're going to go with this problem here. And what this problem asks us to do is to start, because it's a problem involving fractions, by wrapping parentheses around the entire numerator and entire denominator. Now, if something is factored like this, I will say that you can write your parentheses like so. Whenever you know that two things are being multiplied, I'm okay with you jumping straight to that step of writing it this way. Normally we would write it across the whole top and factor it out, but since this problem came pre-factored for us, we can go ahead and do it like this. So getting back to our chart, it says decide which operation. We're multiplying. Multiply straight across to create a single fraction, meaning that we are going to take this times all of that. We're going to take this 3x squared on bottom times the 10 and the x plus 4, and we're going to make a single fraction. We now have a bunch of stuff on top times each other, a bunch of stuff on bottom. Next, it says that we need to fully factor the top and bottom. We need to factor all groups fully. So here's a bunch of groups. Let's factor them out. X plus 4, done. This group right here, there's nothing we can do with. It is fully factored. The 3x squared we could break into 3 times x times x. We'll see if that's useful, so we'll leave that for the moment. X plus 6, fully factored, leave it. Down on bottom again, 3x squared. We'll see if it's worth factoring, but we could. 10 could factor into 5 and 2 if we needed to. And then the x plus 4 group is a whole group that's totally fine the way it is. Since our next goal will be to eliminate things from top to bottom, we should look if these options here are worth factoring further, since they can be broken down. And as I look at them, I see there's an entire 3x squared group on top and bottom that's completely identical. So there's really no need to break these down further in order to achieve things that are exactly the same. We can completely cross out all of them when we get to eliminating. So I'm not going to bother breaking those down, and that 10 won't match up with anything, so I won't bother breaking that down either. I'll just leave it as is. Back on the flowchart, it says before eliminating, check denominator for excluded values. In this case, our excluded values are going to come from here, where we have an x, and here where we have an x. When I look at these, if I look at this example, what plus 4 equals 0, that would cause the whole denominator to become 0. It's when I plug in x equals negative 4. Negative 4 plus 4 would equal 0. So that group would cause the whole bottom, the whole denominator to equal 0. This other one here, when there's no plus or minus in a group, 3x squared equals 0, plugging in an x equals 0 will make that whole group go to 0. So x equals 0. And that's always true when you have some group like this that has no pluses or minuses inside of it. It's just something with an x or x to some power. So those are my excluded values. Always good to write those on the side. And then finally, the last step, it says cross out or eliminate anything top to bottom, numerator, denominator, that's exactly the same. We said these groups are exactly the same, so the whole thing can go. We have an x plus 4 group that's exactly the same top to bottom, both can go. Leaving us with a simplified fraction of only x plus 6 on top, and then a 10 in the denominator. So x plus 6 over 10 is our simplified fraction. It does not reduce farther. You cannot reduce the 6 and the 10 because you have nothing you can factor out of the entire top. The x would be not changed in the same way. So that is our simplified fraction. And let's do one more example that is not factored to start with. And I'm going to go through this one without the chart, but you could follow along in the same way. So start out with parentheses around everything. We then move on to multiply the top and bottom. We actually carry out this multiplication of two fractions by multiplying the top and multiplying the bottom. pieces, and so we now have a single numerator and a single denominator that just is broken into 2 chunks each. We're now next step is to fully factor everything. So when I have terms like this in parentheses and I see that they share something in common in every term in the parentheses, in this case a 4r squared is in common, I can factor that out. 4 divided by 4 is 1. R to the third divided by r to the second is r to the 1, minus 4r squared divided by 4r squared is going to be simply 1. So 1r to the 1 minus 1. Also could be written as just r to the just simply r minus 1. And that's going to look similar to what we see on bottom. So that will be a more useful way to write it. Times the 1. I can actually choose to not rewrite times the 1 because anything times 1 is itself, so I'm going to cross that out as being unnecessary now that we have something else in the numerator. Down below we have 3 terms here and none of them have anything in common. And so the way you factor something like that is you try to multiply to the end and add to the middle so you can get 2 binomials. Something like this. Now if I look at the number 8, just put that up in the corner here. The number 8, you can do 1 times 8 to multiply to 8, 2 times 4, 3 doesn't work, and then you're back to 4 times 2. I want to add to 6, so that one right there, 2 and 4 will add to a positive 6. I'm going to do r plus 2 and r plus 4. Cross out that since it is now factored away, and r minus 1 is fully factored, so I'll leave that. Next step will ask us to look for excluded values from the denominator. I have 3 here that I can work with, and in this farthest right one here, the r minus 1, I know that I can plug in a 1 for that, so I can plug in r equals 1, and that would cause that to equal 0. In this next one here, the r plus 4, I can do r is equal to negative 4 and cause that to be 0. And then finally in r plus 2, r could equal negative 2, and negative 2 plus 2 would equal 0. So these are our excluded values. Write that somewhere that's clear so everyone can see that. And then finally, last step, it says cross things out top to bottom that are exactly the same. We have the r minus 1 and the r minus 1 groups. Remember how we rewrote that to make sure it did in fact look the same. We have a 4 times an r squared on top, and then we have other stuff inside of parentheses down below, and none of that's going to cancel out with each other or factor away. So we are left with 4r squared on top over r plus 2 r minus 4. Or sorry, r plus 4. So our final fraction right there reduced would look just like that. Good luck.